So if you can open up, we're on part B of lesson 6, and yesterday we talked about the quadratic formula. And our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so this is recording, yeah, and yes, I did sing, and please do not put that on the web. Okay, so there's three possible ways that our quadratic formula can work out. And when do we use the quadratic formula? When what doesn't work? When we can't? Oh, I know. It's when it's like an irrational. Can't. I'm going to say the word. We can't factor. So we can't can't algebraically solve it. We can't factor. So we use the quadratic formula when we can't factor. And there's three cases we're going to look at today. And if you have a study sheet, if you can pull it out, we're going to write down these three cases right now really quickly. Okay? So, case number 1, case 1 is that there's two x-intercepts. Okay, that's the first case. So, that would be a graph where it could be opening up or opening down. And it crosses the x-axis twice. Okay? And we're going to, so this would be going on your study sheet or somewhere else. I need to write this down. So case 1 is there's two x-intercepts. So it crosses the x-axis twice. Okay? And this will happen if we use our quadratic formula. We'll just get x equals negative b plus or minus. And there's going to be a positive number inside. All over 2a. Okay, so there's a positive 2 number, so then we can actually evaluate it. And there's going to be two answers. Okay? The other case, case 2, is how else could the graph look? Not like that. So we either can cross the x-intercept. There's three different cases. One, it crosses twice. Can you guess what the other case is? It crosses it once. It's basically the vertex is on. Oh, that doesn't look very nice. Let's try that again. The vertex is on the x-axis. It's really nice. Anyways, I think my smartboard needs to be realigned. How about this? Haha. There we go. Okay, so the case 2 is we have one x-intercept. Okay, Stacy, can you move over to here? One x-intercept. And how will this occur? Will this occur when we plug in our formula, negative b plus or minus the square root, and the inside is equal to 0. The inside under the square root is a 0. And so what happens is plus or minus 0, it doesn't change it. It just becomes negative b over 2a. Okay? So if you ever get a 0 under the square root, that means there's only one solution. It only touches once. And the third case, what do you think the third case would be? Nope. Nope. So either twice, once, or no x-intercept, 0 times. So it's a bit shy. Yes. So our third graph would look like it just doesn't cross at all. Oh, I don't know. Case 3. Thank you. So no x-intercepts. And so if you're working with your quadratic formula, negative b plus or minus the square root, and this has a negative number inside the square root. Because can you take a square root of a negative? No. And so if you ever have a negative number inside the square root, that's not possible, and so there's no x-intercepts. So those are the three cases. You could either cross twice, once, or not at all. Okay? You can also, could you just graph it and look at it and see? Yeah, you could. Okay, so going back to our question. Let's look at number 3. Explain how you can determine the zeros of a function using the quadratic formula. So let's use the quadratic formula here. Okay, so quadratic formula is x equals negative b. B of b squared minus 4ac all over 2a. Okay. All over 2a. You don't like the a? Okay. What is your a value here? A is, oh, just 2 seconds. 4. Okay, so our a value is, what's the a value? What's the a value? 4. Remember A, B, C? Just like your alphabet? Sure, still learning that. Okay, A equals 4. B equals? 12. Negative 12. And C? 9. No, I'm recording. Okay, so A is the number in front of x squared. B is the coefficient in front of x. C is the constant. Yeah. Okay, so here we go. Now, instead of writing negative 12, what could we write? Go straight to 12, just plus 12. Plus 12, plus or minus the square root of. So positive 12, plus or minus the square root of negative 12 squared, minus 4. Yeah, because when you square a number, it becomes positive. 4 times A is? A? 4, and, oh yeah, C, 9. 4 times A times C, all over 2A. Okay, so we're just we're gonna figure out the inside right now. So we're gonna grab the inside of our, grab your calculators. We're gonna type in the inside of the square root first. Oh, sorry, yeah, you're right. 2A should be 2 times 4. Well, because the formula is negative 4 times A times C. So negative 4 times A is 4, C is 9. No, 4, just the coefficient. There's no x's in here. Okay, so with your calculator, grab the right thing here. We're going to plug in just the inside of the square root. So bracket, negative 12 squared minus 4 times 4 times 9. What does that give you? 0. So that equals 12 plus or minus the square root of 0 over 8. So it only touches once because square root of 0 is 0. So it's really just equal to 12 over 8, or what's 4 over 3. Divide both by 4. Actually, it's not. 3 over 2, 1.5. And so this graph, this is 1, 2. It's going to look like, does it open up or down? How do we know it opens up? Positive a value. So it's going to look like something like that. So if we look at our graphing calculator, go to y equals. Plug in 4x squared minus 12x plus 9. Which graph? And there you go. It only touches once. Okay, so it says, what do you notice? What did we notice? That inside was 0. Okay. Okay, so let's look at the next function. So again, let's plug in the quadratic formula. So what's our a value? 2. B is negative 5. C is 10. So x equals negative b. Plus or minus the square root of b squared minus 4ac all over 2a. Yeah. There's the new ending. Okay. Okay, no. Okay, so negative b. So if b is negative 5, we're going to write, if it's negative 5, just positive 5 plus or minus the square root, negative 5 squared minus 4 times our A is 2 times C, which is 10, all over 2 times 2. So let's figure out the inside of our square root now. So grab our calculator. Okay, just the inside. So negative 5 squared. What happens when you square? Positive 25. Oh, I forgot to close a bracket. I hate when that happens. Okay, minus 4 times 2 times 10. 80. 25 minus 80, what? Negative 55. What do you notice? It's a negative inside. So negative inside. Can you take the square root of a negative? No. Okay, so negative inside. Can we take the square root of a negative? No. So will it have any x-intercepts? Guys, pay here. Attention here. What does this girl need? A cowboy outfit? You to pay attention to her? Okay, is there any x-intercepts? No x-intercepts. So let's graph this and see what it looks like. No x-intercepts. Whenever you have a negative inside the square root, non-real. Okay, so let's go y equals, plug in 2x squared. Is this guy going to open up or down? Up. Positive a value. There he is. He's way up there. So roughly, he's like up here. Okay, so 0 x-intercepts. And next page. Almost done. Oh, there's our 3 cases. Moving on. So in the previous example, we've shown that the quadratic function may have 2 zeros, 1 0, or no zeros. Let's highlight. I'm going to use my new highlighters. My new highlighters are awesome because I can go thinner. So you can have 2 zeros, 1 0, or no 0. This means that the quadratic function may have 2 x-intercepts. It can have 1, or it could have no x-intercepts. Or it could have 2 roots, 1 root, or no root. You don't like that color? Okay, let's try again. Just bigger like that? It's really, I agree. There you go. Okay. So the quadratic formula can help you figure out how many zeros you have. In fact, if you just figure it out, b squared minus 4ac, if it's positive, right, then there's going to have 2 zeros. So if that's greater than 0, then there's 2 x-intercepts. If b squared minus 4ac is less than 0, or a negative, 0 x-intercepts. And if it is 0 equals 0, then you have 1. Okay, so really, if you were just checking how many you need to see, how many x-intercepts, you could just figure out b squared minus 4ac. Just figure out what's underneath the square root. And from there, you don't have to figure out all the rest of it. Okay, so remember when they say solve by inspection, what are they really saying? Factoring. Yeah. Sorry, I should have waited. My fault. Better wait 10. Okay. So the rest of the homework is 5 to 10 all for today. So some of you still need to finish off yesterday's homework, which was 1 to 4, and then today is 5 to 10. And that is your homework. And then we only have lesson 7 left. We might do it in 2 days, 2 parts. So that would bring us to Thursday, and then we'll probably have your unit exam on the Tuesday next week. But we'll see how tomorrow goes. We're basically almost done our last lesson. This was our second last lesson.